Hi, my name is Chip Zoller. I'm a technical product manager at Nirmata, and in this session, I'd like to go over some tips on how you can use Kyverno to help you in your daily jobs with platform automation needs. First, a quick agenda. We'll do a very brief overview of Kyverno, talking about what is it and what does it do. And then we'll dive right into these three use cases specifically designed to help in platform automation cases: copying and syncing of config maps, refreshing environment variables and pods, and cleaning up resources like bare pods. So for a brief overview of Kyverno, for those not familiar, Kyverno is an admission controller that's purpose-built for Kubernetes. It is not a general purpose admission controller. Because it's purpose-built for Kubernetes, all policies are written as standard YAML, which means that no programming language is required to implement policies, either use of a programming language or even knowledge of a programming language. You get to recycle the existing skills and knowledge you have with Kubernetes to write policy that can accomplish a variety of use cases. It's also the most popular policy engine for Kubernetes. Kyverno has a lot of different capabilities, all of which we're not going to cover here, but these are listed below. Kyverno can validate resources. This is your quintessential yes or no response that most policy engines begin and end at. Here's a resource from the API server. Should it be allowed, yes or no? Kyverno also has the ability to mutate or change resources that are submitted to it, both new resources as well as existing resources in the cluster. One of Kyverno's seminal capabilities, which makes it super popular for platform and DevOps teams, are its generate capabilities, the ability for Kyverno to create all new resources based upon a policy that you define in the cluster. It can also verify images to ensure software supply chain security. So if you have images that are signed or attestations that are generated on those images, Kyverno can validate those things before the image is allowed to be pulled in the cluster. And Kyverno can also clean up, that is, remove resources based on a policy of your decision. Now, the two with the rocket ship next to it are capabilities that aren't found in any other policy engine that make Kyverno especially attractive for platform teams. And all three that are highlighted are the ones that will be shown off here in this demo. So because Kyverno is very vast, and many may be familiar with its validation capabilities, we're not going to cover that. We're going to cover specifically the capabilities that can help you in your platform job. So for the first use case here, let's look at its ability to copy and sync config maps. So here's a common problem. You have a config map that needs to exist in namespaces across your cluster because pods need to consume that. And as many of you may know, a config map, like a pod, is a namespace resource. And in order for a pod to take advantage of a config map, it has to exist in the same namespace as the pod. But there can be a challenge when it comes to managing all of those config maps, both making sure that they exist and also making sure that they have the same content, because the contents of things like config maps and secrets tend to change. So in this case, imagine that a config map is a certificate, maybe that's from your internal PKI that you use to attach to pods so that they can all trust whatever your internal resources are. We're going to have this in a centralized namespace, just one namespace called platform. And what we want is for that config map to go to both existing namespaces as well as new namespaces that are created after the fact. We can use Kyverno in this case to synchronize, to clone, and then synchronize that config map down to both existing namespaces and new namespaces. And here in the diagram, you can see that we're going to source the config map from a namespace called platform. And then we're going to push it down to an existing namespace named existing. And we'll also create a new namespace called new. And we want and expect the config map to be pushed down to both of those locations. So let's flip over here and go to our demo. And first, let's take a look at a common config map. So here's a common config map that has a certificate that's in it, and you can see that it's named org-ca, and it's going to live in our platform namespace. So first, let's go ahead and just create this. So org.ca now exists. And now we're going to create this Kyverno policy, which is called a generate policy, which is going to take the config map that is in the platform namespace. So here's referencing our org.ca config map, and it's going to clone it. There's the clone declaration. But it's going to match on any namespace, both new and existing, and it's going to clone that secret or that config map from the platform namespace to whatever the name of the namespace is. So let's create this policy and see if in our existing namespace we got a config map. And you can see here that we did get the config map org.ca that was generated. And also, since we don't have a namespace called new, let's create the new namespace now. And what we expect to see is when we do that, inside of the new namespace, we get the org.ca, which we do. So you can see here that Kyverno is able to clone that config map to both existing and new namespaces. And also, if we were able to, if we needed to update that source config map, those changes would be propagated down. So you can see how Kyverno can be used to short circuit a lot of the other additional automation that you may have in the cluster, as well as eliminate existing tools, which can help. So let's go on to the second use case here. This is refreshing environment variables in pods. So here's the challenge. Whenever a pod is consuming a secret or a config map as an environment variable, should that secret or config map change, the pod has no knowledge of it. It won't automatically pick up the new value. You would have to find some way to restart the pod so that at the time that it restarts or is created, as it were, it then picks up the changed value. We can actually use Kyverno to automate this process for us. So going back to our existing namespace, we have a deployment, which is consuming a secret, and that deployment is spawning pods. Now, not shown here as a replica set, but we understand that a replica set is an intermediary resource controller. So deployment already has pods that are spawned, and it's consuming a secret. Now, what we want is Kyverno will watch that secret for any changes. And if a person or a process makes a change to that secret, Kyverno can snap into action, and it will annotate the deployment in such a way that it will cause a new rollout to occur, which will generate new pods that get the refreshed secret. And once that's complete, the controller will tear down the existing pods. So let's flip over to our demo and see this one in action. So first thing, we need to grant additional permissions to allow the Kyverno service account to update deployments since it doesn't have that permission by default. Now that we've done that, let us go and create, first of all, the original secret. So here's a secret. Now this is like an API token, and in fact, it's under a key called token. This is going to be called blue secret, and it's going to go into the existing namespace. And you'll notice here that we have it labeled with something so that we can identify it as a dynamic watch. This is a label that you can use. You can configure any way that you want. I just chose this value. So we'll first apply the secret. And now our secret's created. We can create a deployment that will reference the secret. So you can see it's just a standard busy box. We're going to sleep, and the name of the environment variable that we expect is token, and we're going to pull it from that secret. So let's apply this. And this is also, by the way, in the existing namespace. And so let's get the pod. And let's also, just to confirm, let's exec into that pod and look at the value of the token environment variable. And you can see here, 0628 is the value, and that corresponds to the original secret. So everything is all good. now we need to make a change to the secret because our API token gets rotated. So we need pods to take advantage of that. So let's update the secret. And you can see here, I'm going to apply this manifest that changes the secret to this value, an ending value of 5 echo 2. And so there's the value encoded. So I'm just going to apply this, which will update that secret. Actually, sorry. First, we need to create the policy. And let's step through the policy real quick. So this policy is going to watch any secret that has that label assigned to it. It's going to specifically watch for an update. And if an update to any secret occurs, it's going to go find all existing deployments that mount that secret under the secret key ref. And it's going to write into the pod template. So this is under the pod template area, an annotation called corp.org/random. And we're just going to put some random string in there that's 8 characters long. Could be a static value if you wanted to, but Kyverno has the ability to generate random strings, which can be useful in a lot of different ways. And when this is done, changing the pod template is going to cause the deployment controller to see that change and to roll out new pods. So Kyverno is going to automate all this process with this simple looking rule that's here. So let's first apply this. And now that that's done, now we can change the secret value because it's now putting out a watch on that. And what we expect to have happen is when I flip back over to the existing namespace, we ought to see new pods spawn. So let's see if we do. And you see here that as of 3 seconds ago, we have a new pod that was spawned, and it's now terminating the existing one that we ran just a couple minutes ago. So let's see if we can confirm the value in here. And we should see, if it happened properly, that the token environment variable was refreshed with the new or changed value of that secret. And you can see here, 05 echo 2, 05 echo 2, new pods respond that effectively cause the changed secret to be picked up and reflected in the environment variable. So very helpful. So let's clean up this demo. Okay, so as you can see here, Kyverno is able to help in closing a gap that the Kubernetes API server can't necessarily do. This can be really useful to you in your platform jobs as you potentially eliminate another tool, or maybe you get an ability that you didn't have any other way. All right, so let's move on to the third and final use case here, and this is cleaning up resources. Now, there's a new ability as of Kyverno 1.9, which was just released recently, and this is the ability to clean up resources, that is, delete resources in a cluster based upon a policy of your design. And so here's the problem with this one that we're trying to address. Those of us who've worked with Kubernetes for any amount of time typically have needed to do some sort of troubleshooting that involved running something like a bear pod, whether you're doing a ping check or a DNS test or a connectivity test between some other pods. One of the things that's extremely common is to imperatively run a pod, which is not owned by any sort of higher level controller like a deployment or a stateful set or what have you. But very commonly we forget about these things. And especially if you're operating in a cloud environment, those things have cost. They chew up resources and they can cost additional money if you do it at enough scale. So what we want is a Kyverno policy to help us in automating the process of cleaning up our cluster and keeping things tidy, thereby keeping costs down, keeping complexity down, all of those things. So in this use case, we'll spawn some bear pods in these 3 namespaces, so platform, existing, and ing for engineering. And these are going to be simulating troubleshooting pods of some sort. Then we want to install a Kyverno policy, which will, on a scheduled basis, go and clean up or delete those pods, but not any other pods, just specifically the ones that we're interested in, which are bear pods, pods that are not owned by a controller. So let's flip over and do that right now. And first, let us spawn some bear pods. So these are pods in each of those namespaces, and they're just like in this the previous demo, these are just some busy box pods that are doing nothing but sleeping. So let's create these. And now we've got some pods out there running. And you can see here they are down at the bottom. Now, the next thing that we need to do before we clean these up is we need to grant, just like in the previous one, Kyverno additional privileges to delete pods. It doesn't ship with permissions to delete things since that's a risky activity. So Kyverno expects that you're going to do that based upon your decision. So we'll create this cluster role, which will give Kyverno the ability to do that. And by the way, you'll notice that you don't need to modify an existing cluster role. Kyverno will aggregate a custom cluster role that you want if you're using the aggregation labels, which I am here, which makes it easy to add additional privileges without having to change cluster roles that might be coming from Git, for example. So now we've given that permission. Let's take a look at this new cleanup policy that's possible in 1.9. So in this policy, we're going to match on pods. And we also want some specific conditions to further refine that match. And the cleanup policy can use the familiar tripartite expressions under a condition. So key operator value that you're already familiar with in Kubernetes itself. And in this case, we're looking for pods that do not have an owner reference. And that's what this expression does here. It's looking at the owner references portion of a pod metadata, which is what would be populated if the pod was owned by some sort of a controller. And in this case, we're specifically looking for pods that do not have an owner reference set. So anything that does, it will be skipped by it. And the schedule determines how frequently this is going to run. Now I'm running it every minute here. This is probably not something you'd want to do in production. In fact, I recommend you probably don't do it in production. But in the interest of time, we're going to run it here so that we can see the results quickly. So let me again get those pods. So these are the 3 pods that we just created a moment ago that are bare pods. And now let's create this cluster policy and see if this does the job. So we'll give it a moment here to clean up these resources. And what we expect is when that 1-minute interval comes along, the cleanup controller gets called, and then it goes and looks at resources across the cluster. And then it applies this conditional check to it. And it checks every pod to make sure that it does not have an owner reference. If it does have an owner reference of any kind, it doesn't care what it is, it's going to skip over it. Only if it has no owner reference will it pick it up, and then it should remove those things. So now, maybe we've given that enough time. Let's go and run the same query. And we can see that they're in the terminating status right now. So we should now be able to confirm that that was the result of the policy. And I'll use cleanpol. And let's do a describe on this. And we can see here in the messages that the policy has been applied and it's successfully cleaning up the target resource, the bare pods that are in those 3 namespaces, as we expect to have happen. And so with that, that concludes the demo here. And so I hope you've seen in these 3 use cases that, number one, they're practical use cases that impact you, and that also Kyverno is far more than just a validating admission controller and can actually be a very helpful automation tool that assists in performing your job and maybe along the way reduces complexity. It allows you to eliminate other tools. Maybe you're using some bash scripts that are out there. And so it can be a really helpful thing, not just for security teams, but for you on the platform side. And with that, thank you for attending my session, and I hope that this was useful.